A student raised their hand and gave an answer. And the teacher said, "Not quite. Who else?" 4 words. Not quite. Who else? And the student who answered put their hand down, picked up their pencil, and did not raise their hand again for the rest of the lesson. Not because they were embarrassed exactly, but because the message was clear enough. That answer was not worth examining. It was not quite. And so we're moving on. So now I want to tell you what that answer was. The student had said that 7 times 8 was 54. And yes, 54 is incorrect. 7 times 8 is 56. But here's the thing about 54. I don't think it was random. I don't think it was a careless error. 54 is 6 times 9. And what that tells a teacher who's paying attention is that this student may know their facts. They may have just retrieved the wrong one. Or the multiplication knowledge might be there, but the retrieval got crossed. And a teacher who knows that can do something very specific and very useful with it. A teacher who says, "Not quite. Who else?" never finds out. That student's wrong answer was the most valuable piece of information in the room, and it disappeared in 4 words. Welcome to Show Me the Math Receipts. I'm Sally Smith, founder of Number Navigators, and this is episode 13. We're going to be talking about what wrong answers are telling us and why the classroom that treats mistakes as data produce mathematical thinkers that classrooms treating mistakes as problems to move past never will. So let's get into it. Over to you, Josh.
It's time for Math Joke of the Day. How do you maintain heat in a cold room? Go to the corner. It's probably 90 degrees there. Ba-dum-bum-ching.
All right, thanks, Josh. Let's go. Let me describe what most classrooms do with wrong answers, and I want you to notice how familiar this might feel. A student answers incorrectly. The teacher responds in one of a few predictable ways. They say, "Not quite," or "Not exactly," or "Good try," and immediately redirect to another student. Or they rephrase the question in a way that steers the original student toward the correct answer, which means the teacher is now doing the thinking. Or they simply say the correct answer themselves and move on. Because there is a pacing guide and a lesson to finish and 27 other students waiting. I get it. In all of those responses, the wrong answer is treated as an obstacle, something between the class and the correct answer that needs to be cleared away as efficiently as possible. And what that means is the wrong answer disappears. It gets corrected, redirected, or moved past, and nobody in the room, including the student who gave it, ever finds out what it was saying. But here's what I want you to hold on to for this episode. A wrong answer in a mathematics classroom is never random. It's always the product of a student's thinking. And that thinking, however flawed, however incomplete, however far from the correct answer, is a window into what the student understands, what they have misunderstood, what they almost understand, and what they need next. And when we close that window in 3 or 4 words, we lose the most important diagnostic information available to us. The wrong answer is not the problem. It's the receipt, and reading it carefully is the whole work. The research on error analysis and mathematical learning is deep and points consistently in the same direction. John Hattie's synthesis of thousands of educational research studies, published in his landmark work, Visible Learning, identified providing formative evaluation as one of the highest impact instructional practices available to teachers. And the most powerful form of formative evaluation was not a quiz or even an exit ticket. It's the examination of student errors in real time, because errors, analyzed carefully, tell a teacher exactly where the gap lives, not approximately or generally, but specifically. And specific information produces specific instruction. And specific instruction is what closes gaps. Magdalene Lampert's research on mathematical discourse showed that classrooms where students' errors were examined publicly, where wrong answers were treated as objects of collective inquiry rather than individual failures, produce students who are significantly more willing to take mathematical risks over time. And mathematical risk-taking, as we have talked about across this show, is the engine of mathematical growth. You cannot build it in a classroom where being wrong feels dangerous. And you cannot build it in a classroom where wrong answers appear before anyone has had a chance to learn from them. And then there's the work of researchers like Susan Jo Russell and her colleagues at TERC, whose studies on mathematical reasoning consistently showed that the deepest mathematical conversations in elementary classrooms happened not when students were producing correct answers, but when they were examining incorrect answers. Because an incorrect answer asks a question. It says, here's a place where the mathematics is not yet fully understood. What's happening here? And that question explored together builds the kind of collective mathematical thinking that individual correct answers never could. So let me show you what error analysis can look like when it's done well. Because it's not complicated, it's just intentional. So imagine a student in the fourth grade. A fourth grade classroom, and they say that 1/2 plus 1/2 equals 2/4. And the teacher does not say, not quite, who else? The teacher says, tell me more about how you thought about that. And the student explains, well, I added the tops and I added the bottoms. And now the teacher has something. Because what that student just described is a completely logical application of a procedure that they've seen. Except they applied it to a context where it doesn't work. They added fractions the way you multiply fractions. And the reason right there is that nobody has ever helped them understand why you don't add the denominators. The procedure was taught. The reasoning behind the procedure was not. So the teacher does not correct the student. The teacher asks the class, does everyone agree with this? And now the whole room is thinking. And a student says, wait a minute. But 1/2 plus 1/2 is 2/2. And then 2/2 and 1/2 are the same thing. So the answer should be 1. And the teacher says, interesting. Can you show us why? And now the mathematical conversation is happening. The wrong answer opened it. And every student in that room, including the one who got it wrong, is building something that they never would have built if the teacher had just said, not quite, who else? That is error analysis. And it's available in every classroom, in every lesson, with every wrong answer that comes through the door, if the teacher has been taught to read it. If you're a classroom teacher, I want to offer you one reframe that will change what you do the next time a student gets something incorrect in your classroom. Before you respond, ask yourself one question. What does this error tell me about what this student understands? Not what did they get wrong? What does the wrong answer reveal about their thinking? Because those are different questions. And the second one is the one that produces instruction. If you are a math coach, error analysis is one of the most powerful lenses that you can bring to a post-visit conversation. Not how many students got the answer right, but what did the teacher do with the wrong answers? That question, asked consistently, shifts the entire frame of what good instruction looks like, from answer production to thinking examination. And that shift is worth every uncomfortable conversation it takes to get there. If you're an instructional leader, look at your assessment data differently. Not just which standards students are missing, but what the errors on those standards look like. Are students making random errors or patterned ones? Because patterned errors are not failure. They are information. And a school that reads its error data as information rather than indictment is a school that knows exactly what to teach next. And if you're a pre-service teacher, before you ever say, "Not quite, who else?" build the habit of pausing. One breath, one question. Can you tell me more about how you got there? That pause, practiced until it's automatic, is the difference between a classroom that learns from mistakes and one that just corrects them. And the students in the first kind of classroom grow faster every single time. Three things this week. Number one, collect one wrong answer per lesson and examine it. Not to correct it publicly, to understand it privately first. Before you respond to a student error, take 30 seconds to ask yourself what the error is actually revealing. Write it down if you can. Over time, those notes will show you patterns. And patterns are where your most powerful instruction decisions live. Number two, try this phrase. The next time a student gives a wrong answer, replace "not quite" with "interesting." Say more about that. Say more about how you thought about that. Those words change everything. They signal that the thinking matters. They keep the students in the conversation, and they give you information that "not quite, who else?" never will. And number three, make one wrong answer a class discussion. Once this week, just once. When a student gives an incorrect answer, bring it to the whole class. Not to embarrass the student, but to examine the thinking together and say, "Here's what someone said. Does this make sense? Why or why not? What is happening in this reasoning?" That conversation, facilitated with care, teaches more mathematics than 10 correctly answered practice problems. And it tells every student in the room that being wrong here is safe, which is what we talked about back in episode 6. It's the whole foundation. So here's what I want you to carry out of today. The wrong answer is not the end of mathematical conversation. It is the beginning of the most important one. It is the place where thinking lives, where the gap is visible, where the instruction can actually meet the student instead of moving past them. And so the next time a student gets something wrong in your classroom, don't clear it away. Read it, because it is a receipt. And receipts on this show are always worth keeping. Next time on Show Me the Math Receipts, we are leaving the classroom for a moment and heading somewhere the mathematical conversation is also happening. Somewhere that shapes what students believe about mathematics before they ever walk through your door. So come back for episode 14. I'm Asali Smith. This is Show Me the Math Receipts. And until next time, teach boldly, protect student thinking, and always keep your math receipts.